Today we're going to talk about when tech meets the carbon footprint. We're going to discuss a little bit about technological enhancements of wood as a building material. Today we would like to discuss that with two of our industry partners that we have in the house today. One of them is Pekka Ritvanen. He is the CTO of a company called Avant Wood in Finland. And further do we have in the house the greenest man in the world, Matthias Gelber. So today, guys, we would like to discuss a little bit more about wood as a building material. Now, of course, all of us know wood as a building material in the old days, but then we all went to bricks and metal and metal and cement and stones. Now, at this moment, of course, with the deforestation in many parts of the world, we can see that using wood seems not the most logical thing. What is your answer to that, Matthias?
I mean, wood has the amazing benefit of sequestering carbon, absorbing carbon. And we have the mega trend in the construction industry that we realize we need to both bring the buildings in operation down to zero carbon and the construction material. Wood is the only option for that. Your shelf behind you, because you're moving, Frank, is empty, but it has absorbed a lot of carbon dioxide because it's made from wood. And deforestation is only a problem when we don't manage forests in a sustainable way. If we increase the commercial viability of reforestation and manage it sustainably, and we have plantations that are certified to Forestry Stewardship Council or PEFC, then we have actually the plantations that can deliver sustainably managed forests, including biodiversity. That's what we need on a large scale to sequester carbon instead of emitting carbon, which is the huge problem of steel and cement. And if we do it, we have a double whammy. We can avoid the CO2 emissions from the use of steel and cement, and we can have a material that has sucked up CO2, gets sucked up, gets turned into carbon as part of the tree. That's what we need.
Okay, excellent. Great answer, Matthias. Now, I understand that Pekka, you have developed a technology where you use low-grade wood and turn that into high-grade wood with a high value. As from what I understand, wood normally takes a very long time to grow to be strong enough to be used as a timber for a building material. But through your process, I think you have shortened that process. Can you explain a little bit more about the process?
That is true technically, but I would like to come back a little bit to Matthias' comment. Matthias is right when he's talking about sustainable way of using wood. And when you have a sustainable way of using wood, you would also have a smart way of using wood. In the market, there are new solutions coming up all the time, and wood is being introduced in new technologies, including ours. But they are such that they are based on more on European type of using of wood. They are CLTs, cross-laminated timber, or certain massive things. But you cannot apply the local timber species for those because they are different by nature.
Right. And
what we have done is that we have developed a thermomechanical timber modification process, which we call TMTM by Avant Wood, so that we can apply any timber species and utilize them and make out of them totally new type of end product application. And the smart way is that for example, I will show you soon. This is a core of eucalyptus timber, and I'm having this blue for safety reasons. And this is considered as a trash. But with our technology, what you can do is to saw it like this. Can you see it?
Yes, we can see.
And then modify it stronger, harder, and more dimensionally stable. And then after modification, you can make with the traditional profiling machine, a profile like this, and then do it like this, and oops, there you are having a totally new type of massive timber glulam board or whatever board you want to need it. And then at the second, you can utilize all the timber species throughout the world. As I showed to you, eucalyptus, this board is made of acacia and rubber wood. Okay. So there are no limits practically to use the TMTM for local challenges.
Fantastic. It shows that you show again that wood should be considered as a building material. How are you at the moment approaching the market, and in which areas are you working in the world with the TMTM technology?
Sorry, we are now working primarily in the Southeast Asian market, but we are active in New Zealand. We are active in US and NAFTA area, in Germany, and we are not when conventionally people buy and sell timber, it's a commodity, and you buy and sell commodities. But what we do is that we sell and offer our customers new solutions to improve the utilization of timber. And so we are, even if we are a startup company, we are quite active now worldwide, and it's picking up when we are making new test runs and customer specific modification of timber, so that the customers, they make totally new products for themselves. We get the competitive edge, and our customers will have a competitive edge.
And I think, Frank, adding to that, what is really amazing with this technology, the acacia wood or rubber wood, like the acacia wood board that we just saw, this will usually, in places like Vietnam, and I think that sample is from Vietnam, it will be turned, yeah, this is from Vietnam. It will usually be used as wood chips that go into power plants under the umbrella of renewable fuel. Yep. But the problem is we're automatically releasing the carbon dioxide again. Okay, we have the benefit of replacing coal. It's a bit more eco-friendly, but with the Paris Agreement, we need to lock up the carbon for the next 30, 50 years and give it several life cycles. And this is exactly what we can do with this technology. Instead of having a low value, low margin product that goes up in smoke again, we need high performance, high margin materials like this that can be in the life cycle for the next 50 years. Then we are really contributing to the Paris Agreement.
Yeah. And just briefly, we are not talking about small monies here. Vietnam is the, I guess, the sixth largest wooden manufacturer producer in the world and exporter, about $9 billion US. But for the raw material, most they use imported raw material, and they say that we cannot use our own food resources like acacia, rubber wood, or something else. And at the same time, they are the biggest chip importer in the world. So 9 million industry and the raw material for it can be made 5 times more value added if you just adapt the technology and the opportunities. So that's why we say always global scalable solution for local challenges. If we ask the question from our customer from Panama, for example, they have a totally different problem, but we offer them the same solution principally.
Okay, interesting, because Pekka, you just showed us this material from Vietnam. Were the acacia and the rubber trees used together in that one product that you just showed?
Yes. And as you saw, they are differently modified. Hopefully you can see it's black.
Yes, we can see, yes. Yeah.
And hardwood and sapwood, and
fantastic.
It's I cannot show, but it's at least 2 times stronger than the conventional glulam board. Yeah.
So one more question, because I read some of the marketing materials, and you're all about eco-friendly and green technology. So are there any resins or glues used in the process?
There are, for example, that glulam board, but in the TMTM modification process, we don't use any extra chemicals. We use only steam or water, and of course the water that comes spontaneously out of the timber during the drying time.
Right.
But no, we don't use it any hazardous chemicals in the process.
Okay,
I think this is very important because, you know, classically you have a lot of wood treatment with boron, acids, other nasty chemicals. Here you can densify it. You can make it more weather resistant, more resistant against bacteria just with this process. It's as well IoT controlled, so you are saving a lot of time. You can churn out a lot more in a short period of time, which is the ROI enhancement of this technology. I'm really keen that we bring this technology to a lot of different places, because I think it can help with the Paris Agreement and with helping especially as well small scale operations to really scale up and get higher margins and plant a lot more trees to absorb a lot more carbon.
Okay, great.
I'll show you just for comparison. This is also a logwood board, but as you can see, it's made for flooring.
Right.
And the time for this is birch. And comment to Matthias, the conventional time of drying birch, about 30 millimeter thickness, it's about 300 hours, as we did that in 20 hours. Wow. So the time saved can now offer our customer a possibility to make customer specific end products.
Right.
Not working like a mass production that you have huge facilities to make timber, but unfortunately it's only one timber species and few products.
Okay. So you keep us up to date on that, yeah? But one more quick question, because there's a lot of farms at the moment starting to grow bamboo, because of course bamboo is a fast-growing plant or tree, and that could be used as a building material too. Could that be used in this process as well?
Yeah, we were as well looking at doing tests with that. I mean, bamboo, strictly speaking, is not a tree. It's like a grass, and it has the beautiful benefit of absorbing a lot of carbon dioxide using very little water. You cut it, it regrows by itself. Beautiful product for sustainable construction. And yes, we are very confident that with TMTM, we can as well enhance the properties and make bigger pieces than the current technology that people use out there in the market. And we are familiar with production of bamboo materials here in the Philippines, and they still use some very aggressive chemicals. We think we could massively enhance that as well. So there are unlimited opportunities. We just need to let people know what we can do and scale it up, find the right partners, and that's what we are looking forward to.
Okay, thank you so much. We were going to end the session here. I'm sure that we're going to hear much more from you very soon. I also understand that you're looking for investors, so we'll have a different discussion on that at another date. Thank you very much, the greenest man in the world, Matthias Kelber, and the CTO from Avant Wood, Mr. Pekka Ridvanen. Thank you very much for the session.
My pleasure, absolutely. Thank you.
All right. Cheers.
Thank you. Bye-bye.
Thank you.